Okay, there we go. Exit full screen. They're not paying attention to me. Okay. All right. I think we are ready to go. I'm going to switch masks to this one instead. We are ready to go. So we're going to do, all you guys had to do since Tuesday was making sure you understood all the notes we had gone over. And then yesterday, you guys had a little Khan Academy, just a real small little thing about logarithms and exponents and their relationship with one another. So hopefully you guys are okay. So before we start anything new or anything you want to talk about, let's hear it. So yeah, so what's happening is, I don't know if you guys hear it or not, but like when somebody enters Zoom, I always get a ding dong and I have to let them into the Zoom meeting, right? Which is rough on me. And then I have to also post all those videos online if I want to post them. If I stream live on YouTube, they're automatically recorded there. So if you're absent, you can just go to my channel and you'll always be able to watch. You won't have to find the Zoom. You can just go to the YouTube channel. You can watch it. If you can't watch it during the day, you can go there at night and you can just watch the recording of it. So that's the whole purpose of changing it to using a channel on YouTube instead. Okay. And it still shares the screen the same way, so you can still see it really nice and neat. You'll still see me in there, but we're just going to go through a little bit different platform for ease of myself of posting videos and not having to worry about people getting kicked out, letting them back in, kicked out, let them back in. That's just a hassle for me. So that's why I'm doing that. Okay, good question though. Anybody else have anything you want to ask? And you all, really and truly, you all should just join it. Okay, and I put something on Google Classroom about it, because if for some reason you are sick, you're going to be able to at least see what happened in class that day. And again, you don't have to go ahead and watch it right away. You can do it at your own leisure. Or even if you're here and you want to rewatch part of it, you can skip ahead and say, oh, this is what I want to see what he said again. Boom, there it is. So it's for your own purpose more than anybody, okay? It's not for me. It's really more for you guys to help you guys out, all right? All right, so that takes care of the YouTube thing. What else? Anything else you guys want to ask about in general, maybe? Anybody? No? Okay. Have you guys heard about next Wednesday?
No.
Okay, so I'll just tell you now. Next Wednesday, we get our first COVID shots, okay? And we've scheduled throughout the day and all that. Next week, there is no new assignments given on Wednesday, okay? So next Wednesday will be kind of like a catch-up day. Like you could be doing things for Monday and Tuesday, studying, whatever it is, but there won't be anything new given to you next Wednesday due to us getting shots on that day, all right? I'll still be here. We're going to be here. So if you had a question and you wanted to email us and set up a Zoom just to talk, we can do that. But again, there won't be any new assignments next Wednesday. Okay, it'll be kind of like a catch-up day for you guys, all right? All right, well, let's go ahead and get started. And as I was thinking about things yesterday, I decided to do this lesson before we go back and revisit word problems. We'll be revisiting word problems starting tomorrow. So if you recall, and if you weren't here, I'll give it to you. I gave you this golden sheet of knowledge. I'll give that to you today. If you weren't here, I think that's Kevin needs one, but we'll be using that tomorrow and talking more about that again. So we are actually going to get going here. And there are some properties of logarithms that we're going to need to discuss. goal today. Some properties of logarithms. Oh, I'm going to grab something real fast. Next week's going to be a chilly one, guys. You hear about that? It's going to be chilly, getting down to single digits, like 1 degree at night. We're going to have some chilly ones. Okay. So we're going to be doing
Mr. Snyder, can you share your screen?
Logarithms today. And before we do the properties of logarithms, I'm just going to put a little quick problem up there. I just want you to try. Okay. So this would be a review problem. Here, open that up. Okay. So I need everybody to rewrite this in a different form. See if you can rewrite this as a logarithm. Just see if you can. Okay.
Mr. Snyder, can you
I
share your
haven't done
screen?
one like this, but I'm just going to challenge you. Can you write this as a logarithm? Copy of this.
Mr. Snyder, can you share your screen?
Any thoughts of how I could write this as a logarithm? What do you think?
Hello.
Are you guys fine? Yeah.
Log base 2 is of y plus 3
Okay.
equals x.
Tell you what, let's do this. Before we do that problem, let me just real quick put a more basic one before it. Change that to a logarithm for me. That should be an easy one for you guys to do. Should be. If you understand what we're doing in here. Okay.
Mr. Snyder, can you share your screen?
So what would that be as a logarithm? Great. I heard it. Log base 3 of y equals x. Okay. Boom. All right. Now,
Mr. Snyder, please share.
on this one, before I can write it as a logarithm, I have to get this by itself. I have to have the base and exponent by itself before I can change it to a logarithm, which means I have to go ahead and do what? Add 3 to both sides. Okay, so I would get y plus 3 equals 2 to the x. Now I should be able to write it as a logarithm. It would be log base 2 of this entire thing. To show that it's the entire thing, I want to put it in parentheses like that. Equals x. Okay? Does that make sense how I just did that? So in order to write it as a logarithm, I have to get the base and exponent by itself on one side of the equation. Then I can change it to logarithmic form. All right. No calculators allowed on this next one. This is, again, review. I'd like an estimate Just using your brain. So all you're using is your brain, okay? Of this. An estimate. It's not going to be exact. It's an estimate. No calculators allowed. Just wait. I'm going to come around and actually, I just need to write something down. I'd like to just see what you guys have. Good. Didn't do that. All right, so in your own words, tell me how I would be able to get an estimate to this without any issues. How should I be able to get an estimate to this problem without really freaking out? If I understand what this is saying, in other words. This is really, do you understand what this is saying? Tell me something you do know. What? Well, okay, 8 squared is 64. So what am I looking for? Some power. Remember, this number over here is a what? A power. It's an exponent. So I know that 8 to the second power is 64. I need 8 to some power to be 68. So it's going to be about what? Just a little bit more than 2. So if you put like 2.05 or 2.1, something, that shows, hey, maybe you put this. I don't care. It's an estimate. If you put less than 2, what would I say? No way. If you put more than 2.5, that's probably not a real good estimate either. Okay? But I wouldn't be as mad. Now, if you put over 3, I would for sure say you have no clue what's going on. This is just, do you have an idea of what's going on? This is what this is about. That's the only reason I asked that. Okay. Okay. Woo! You know what we're going to do? Did we solve some problems in here that were logarithmic earlier in the first couple days? We did, didn't we? We solved some real basic ones in here, didn't we? Yep. I mean, like, if I gave you something like, oh, I don't know, this. Tell me how I would solve that. This is where we were at. How would I solve that? Okay, why? Because this is saying that x squared equals 58. That's what that's saying. And then I know that I would take the square root, and would I use the positive and negative square root?
Just the positive.
Just the positive, because the base must be positive. So here, x would be whatever the positive square root of 58 is, okay? Which I should know is between what? Between 7 and 8, okay? Between 7 and 8, probably a little bit closer to 8. All right? So I should be able to do that kind of a problem. Solve basic exponential and logarithmic equations like we did Monday and Tuesday. All right. Woo! So, what if I got crazy and I did this to you all of a sudden? Oh, I don't know. How about, oh, yeah, that's good. I like that. Anybody have any ideas how I do this one? What do you think, Ryan? So give me your thinking. I like what you said, but kind of give me your thinking. I know what you did.
Because it's the same thing.
They're what then? What do we call same things? We don't call them same things in math. It's okay. That's true.
They're equal.
LT. What? They're like terms, right? They're like terms. And we talked about that when we add and subtract expressions. They're like terms. How are they like terms? They're logarithms of the exact same base and of the exact same value here as well. So they're like terms. So how many log base 2x's do I have? 2 of them. So I could just say, oh, well, this is 2 of these things like this. And then Ryan said he'd cut it in half. That's what you said, right? What you really did was what? Divided both sides by. So that's what I was wanting to say. Yeah, I would just say, oh, divide by 2. Log base 2 of x now equals what? 8. And then I would know that what? X is equal to. What's that? Careful. Write that in exponential form. 2 to the power of 8 equals x. That's the base. That's the exponent. Okay. Careful. I know that's an easy one to say. Oh, yeah, it's not the. We're not. You gotta be careful there. Okay. So there it is. If you can leave it like that, I'd be happy. All right. So you can actually add 2 logarithms like this, combine them if the bases are the same, and this in here is the same. They have to be the same. If these are not the same, you can't combine them. If these are not the same, you can't combine them. Has to have both of those be identical. Okay. All right. So here's my question then. What if I asked you to do this one then? Now what are we going to have to do? Because they're not like terms. Well, guess what? We can't do this at this point in time because we don't have the tools we need. That's why we have to do today's lesson. Okay? Because what we're going to learn today is I need a way of trying to rewrite this into one logarithm. It's 2. I want to rewrite it as 1, like I did in the previous problem. Okay? Because if I can get it down to 1 logarithm, then I can always change from logarithmic form to exponential form. So I need to be able to rewrite this, and what we call it is condensing it, because I'm making it smaller. My goal is to condense that left-hand side into a single logarithm. All right? In order to do that, there are some properties I need to know, and that's what we're going to cover right now. So we can come back and do this problem later. All right. What do you do? Why is that there? I don't know. Here we go. There are 3 of these. Okay? There are 3 properties of logarithms that we need to know. Now, unfortunately, it's funny. We have a lot of properties that have the exact same names. Product property, quotient property. You see these same terminologies show up over and over again, okay? All of these are for logarithms. This is the product property for logarithms. I just didn't type that down every time, all right? So here we go. I'm just going to write it like this. If you have log base b of m plus log base b of n. So now this is kind of like that problem I just had before, right? I've got 2 logarithms with the same base, but these values are different. You are allowed to rewrite that as log base b of the product of m times n. That's why it's called the product property. It's called the product property. Okay, so Again, if I take the sum of two logarithms in the same base, I can rewrite it as a single logarithm with that base, and I multiply these two values, or these two quantities, or these two expressions, whatever they might be. Now, when I go from here to here, I made it smaller. So that's called condensing it. So we condensed it. Kind of like condensed soup. Like Campbell's soup is condensed soup. What does that mean? You have to add water to it. It's been kind of dehydrated somewhat in some way, right? So that's called condensing it. If I go the other way, and sometimes we might, if I go the other way like this and make it larger, that is called expanding it. Okay? And there might be times where we want to expand a logarithm into multiple logarithms. So we need to be able to go both directions. Okay? Condensing and expanding them. All right? Now, that's called the product property. Okay. So you're going to have to know that one. You're going to have to memorize that one. Now, before I go any further, let's just talk about that, and let's go back to that problem we were just talking about before this. Now that I've given you the product property, I could rewrite this. I could condense this and make this log base 2 of what? X squared plus x. It's this times this. Now you could write it as either, you could go this, you could write it like this, if you want, equals 4. Or if you want to do the multiplication in your head and write it as, oh, that's log base 2 of x squared plus x. That's fine. Now notice it's in parentheses. Why is that important? Why is this not okay? Why is this what I want and not this? Okay, here we go. Let me ask you this. Let's say I wanted you to do this problem right here. Okay? What would you do? Tell me what would you do for that one? Yeah. Why? Yeah. How do I know if that 3 is it the log base 2 of that entire thing, or is it log base 2 of x, and I'm going to add 3 to that afterwards? How do I know? I have to use parentheses to show that it's the logarithm of the entire quantity. Those parentheses are important so I know that it's the logarithm of the entire quantity. So please be careful. So when you see this, this is log base 2 of x, and then on top of that, I'm going to add 3. If you see this, this is log base 2 of the quantity x plus 3. Two different things completely. So make sure you understand that. Okay, so that's why I wrote it like this or like this, so I understand. And now, guess what? What can I do there now? Now that I have a single logarithm, what can I do? Write it as an exponent. I can write what? 2 to the 4th equals, and now it's nothing more than what? Solving a quadratic. So in order to do that, I needed to go from 2 logarithms being added down to 1. And that was using the product property. That's using the product property. All right. So that's why we need this. One of our extra tools in our tool bag now for working with logarithms. Okay. Now, that's the product property. Can anybody tell me about the properties product and quotient? Like product and quotient are what kind of operations? They're inverse operations. Guess what? That means these properties are going to be like inverses of each other. Okay, so watch. What's the inverse of adding? So this is going to be about subtracting 2 logarithms. So what's it say? If I have log base b of m minus log base b of n, Okay, guess what? What's the inverse of multiplying two things? Dividing them. It's going to be log base b of m divided by n. So if you understand the product property, the quotient one is just the inverse side of it. Okay, it's just the inverse of it. Right? So now, if I have two logarithms in the same base I'm subtracting, I can condense into a single logarithm like this, where I can expand again. All right. Woo! Doing great. Power property. All right? Power property is a nice one to have as well. Power property says the following. Let's say I have n times log base b of m. Okay? All right. Now, before I write this one down, I'm just going to go ahead and say, hey, what if n equals 3? I'm just going to do an example with a number in place of n. N is a value, right? So that would be what? 3 times log base b of m. Now, we all hopefully know that multiplication is just another form of what, really? In elementary school, you were taught that multiplication is just what? Repeated addition, right? It's just adding the same thing over and over and over again. So what addition problem is this? Yeah. Yeah, this would be log base b of m plus log base b of m plus log base b of m. Okay, now let's look at the product property that we just had. I'm adding together logarithms with the same base, and these actually do have the same value here. But I can still use the product property. What would I do? Well, this would, if I did these two, let's say I just started by condensing these two. What are those going to give me? Log base b, yep, of m squared plus log base b of m. I condense those, multiply those. Boop. Then what would I do? Oh, if I condense those, I would get log base b of m cubed. Do you notice anything about that exponent and what n was? They're the exact same. So what's our rule here going to be? It's very nice. And this is why it's called the power property. If you have a logarithm being multiplied by some constant value, you are allowed to make that the exponent of this value. So this is equal to log base b of m to the n. Again, you can go either way with it. Either way. If I give you this, you can write the blue. If I give you the blue, you can write the red. Interchangeable back and forth. Okay? Interchangeable. Power property. Those three properties are going to be used in solving some equations that are a little higher level of equations. All right. So let me do this. So is there anything here that you want to say anything about or copy down or ask for me to do something else with, or this is your chance? Get my problems ready because I know I have some problems I already wrote down here. Shibbity-ba. Do-do-do-do-do-do. Do-do-do-do. All right. So let's try one here. Let's try something. I want to solve the following. I want to solve this. Start with a nice one here. Okay, I'd like you to try to solve that using now what we know from Monday, Tuesday, and what we've just done. See if you can figure out how to solve that problem. These people, none of them. Okay, I need to let these people know. All right. Woo! Shabow! Help me out. First step, Campbell soup. Condense it. Left-hand side, log base 3 of, if you want to multiply out, you can. What do you get? Yeah. X squared minus 2x. Beautiful. Now what? Exponential. I guess you guys probably, most of you go 3 to the 8th equals x squared minus 2x. That's gross, isn't it? Some big old nasty number. It's like 6,561 or something like that. Yep. Now, we're going to stop here for a second. Now, when I'm looking at this, of course, what would be my next step? Subtract that, because remember, quadratic, you want to make it set equal to 0. I would get x squared minus 2x minus 65, 61 equals 0. Now, I'm going to stop. I want to talk about. You could try to factor that. Or you could do what? Quadratic formula, right? You also could do what with that really if you wanted to? Probably could graph it and find them. Now, those may not be exact answers, though, right? Those would be decimal approximations. First and foremost, I would not give you that on a quiz or a test with a number that large. It would be something that is much more able to be accomplished by either factoring it or using the quadratic formula to get a final answer, okay? So I wouldn't give you like that, but we should, if I wanted, if I made this a different number, you should be able to continue this and keep moving forward with this. As always, what's going to be important? Can anybody tell me something about the value of x I know? What has to be true about my solutions of x here in order for them to work in the original equation? Yeah? Can you go a little further than that? What do I know must be true? X must be something. Here it does, but what about here? Has to be greater than what? 2. I know when I get done solving this, my values of x that work are going to have to be bigger than 2. They'll work here in order, it's this one right here. I know right here, x minus 2 has to be greater than 0, which means x has to be greater than 2. Okay? So I'm looking back up there. So it's not always that x is positive when I solve for. It's always that when I plug it back in, it gives me either a positive base or a positive value of the logarithm. One of the two. So I have to be very careful. Okay? All right. Let me see here. What do I got next? Let's just do it. Let's do something else here. You ready? I want you to try the following for me. Okay. Log base b of x equals 1.209. You okay with that? Yeah? Okay, here's what I want you to find. Find, and this will take us into our break. When we come back, we'll keep going. Find the following things for me. Let's just start with those. Find those two things for me, please. What do they equal? Try those out. You guys take your break. You don't have to sit in here. I'll give you time when you come back in. Take a break. Get outside. Run around, do what you want. Nice to see you guys. How we doing on this? Any clue how to do this? Any clue how to do this? You probably don't like it. It has all those variables in it. These and X's, and it's like, gee. Shoo-ba-doo-ba-doo. I'm just going to write one word on the board. Two. Expand. Expand. Can somebody please expand this for me? Only one person? Two? Oh! Riley, what do you got?
The X and Y one, the first one.
Yeah,
I got long base B of X plus long base B of
I
Y.
love that idea. Product property. There it is. There's my answer, right? Add them up. What am I going to get here? Yep. $2.753. Great. This one now. Let's do that one. Let's do that one in purple. Purple. Now, if I expand this one, it's what?
Subtraction.
Yeah, it's subtraction. Log base b of x minus log base b of y. So that would be 1.209 minus 1.544. And my answer here is going to be negative
0.335.
335. Boom. Okay. There you go. I like that. That's good. Good. All right. We okay with that? What we just did? How we did that? You don't see it maybe at first. Most common mistake is people want to just go ahead and say, oh, I'm just going to take that times this, and oh no. Right? Expand it. Expand it. Oh, we're not there yet. We're not there yet. We're not there yet. Here we go. I'm going to have you condense one for me. All right, here we go. Condense the following. Condense. That means what?
Make it smaller.
Make it smaller. And actually, I want to make it one logarithm, a single logarithm. Actually, let's make that a Z, not a 3, a Z. Condense it. Condenso. La 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 la.
Is it allowed to use multiple
Properties, you bet, but I'd use one at a time. Shabba-dee-ba. I'm actually, while you're doing that, I'm going to, where's that problem at? Where are we at? It's the same problem. Don't freak out. I didn't give you a second one to do. It's the same problem. All right. So I'm going to do this twice just to kind of work you through this. Okay. To show you something. So on the left one here, I'm going to start by just doing this one left to right. All right. I'm going to start by doing this left to right. Now, by doing this left to right, I'm going to start right here. Okay. And I'm going to make this 5 an exponent up here instead. So I'm going to make this log base 2 of x to the 5th plus log base 2 of y. And if I want, I could do this right now and get rid of this power. I'm going to do all the power properties first. Minus log base 2 of z to the 5th. Okay? All right. Yeah,
That would not be a negative 5.
I have this problem up there twice, don't I? We're going to look at that in a second and see if it will. Okay? That's why I'm doing this problem multiple times. Because is that a positive exponent or a negative exponent is the question. That's why I'm doing this multiple times to answer our own questions we have. Now I'm going to go ahead and do, again, left to right, I'm going to do the condensing these two to start, which is product property. So this is going to give me log base 2 of the product of these. So that is x to the 5th y, then minus log base 2 of z to the 5th. We good with that? So far, so good, right? Yes, times y. Correct. And here's x to the 5th times y. Now, one last condensing. I have 2, I got to get down to 1. And now I'm going to use so here I use the product property. Now I'm going to x to the 5th times y divided by z to the 5th. Okay? We good with that? Is there anything you want to ask about the left-hand side that I just did? No. Okay. Now I have this problem up there again. Now we're going to do it a second time. Again, I'm going to go through and take care of the power property first. Do that first. Here we go. So this is going to be log base 2 of x to the 5th, log base 2 of y. Okay, now, the great question was, is that going to become a positive exponent or a negative exponent? If I make it a net, what I have to think of is this could be viewed as plus negative 5 log base 2 of z. It can be viewed as that, right? That's the same thing. So if I view it like that, it looks like the exponent should be what? -5. So let's do this. Now, what's going to happen? It's no longer going to be a minus, it's going to be a plus. Okay? That's all I've done different. Okay, here we go. This part, condense. Log base 2 of x to the 5th times y plus log base 2 of z to the -5th. Condense. Log base 2 of x to the 5th times y times z to the -5th. But I don't like negative exponents. These stay on top. When we did this way back when, this goes to the basement and that becomes a positive. And what do we notice? Same answer. Doesn't matter which way I do it. The key here is if I make this a negative, I have to remember to make that turn into a plus. I just have to be careful, okay? Just have to be careful. Now, I do have a question for you. Do you think it would make any difference if I started off my condensing by doing these two first? Like, would I get a different answer if right here I decided to do these and then did this afterwards? Should it make a difference? And the answer is no, it's not. Not going to make a difference at all. This is going to still give me y times this, and then times this, or y over that, and then it's going to be times this. It's going to give me the exact same answer. I will tell you to go through and take care of power property first, though. Get the powers up on top if you're going to condense it. All right, let's go back down to a single page. And now we're down to our last property of the day. Now, this one's not as important as it used to be. There's a reason for that, okay? Not as important as it used to be. At one time, this was very, very, very important. And for you guys, it will sometimes be important, and I'll let you know when later on, okay? There are some equations that you're going to have to solve that you will need to use this. Change of base formula. If you ever come up to my desk, ask me a question, and I just say Cobb, I'm telling you, change of base formula. That's why I got Cobb up there. I will just say Cobb, change of base formula. All right? So we look at this, and it says if A, B, and C are positive numbers, okay? We know that A has to be positive. We know that C and B, we know that already because that's true for logarithms, right? If A, B, and C are positive numbers with B not equal to 1, B is not equal to 1, and C is not equal to 1. Now, why do you think this stipulation here, why is it that B and C both cannot equal 1 in this equation? I want you to look at it. Do you see where they are? They're right here. What would happen if B and C were both 1? It would give you 0. The log base 1 of 1 is 0, right? So that would be a 0 in the denominator, which would mean it's undefined. So that's why it says that C and B cannot be equal to 1. Now here's what it says. Look. It says that log base C of A is equal to log base B of A over log base B of C. Now that doesn't mean a lot to you, the way it's written right now. Let me go a little further with that. That means it'd be equal to the common log of A over the common log of C. It's as long as these bases are the same, it's true. Or the natural log of A over the natural log of C. Now, how does that help me? Well, watch. If I ask, hey, log base 3 of 12 equals something. Now, right away, you should be able to give me an estimate for this, right? Bigger than what? Between what two numbers should it be? 2 and 3, right? Because 3 squared is 9, 3 to the third is 27. It's got to be between, it better be closer to 2, right? Now what? How can I do this on my calculator? Because your calculators, if you look at them, if you have a cheapo one, whatever, it's got common logs, natural logs on there. If I want to do this, I could just take the common log of 12 and divide it by the common log of 3, and I will get an answer. Or I could do the natural log of 12 divided by the natural log of 3. If you do it on your calculator, you'll see. Let's see here. I'm going to do log 12 divided by log 3. Guess what I got? 2.26 roughly. And if I do this, it'll give me the same thing. It doesn't matter what it is. As long as these bases are the same, it's true. All right? Change of base. Did you, okay, I know you did wrong with that. Did you put your first one in parentheses? Like when you did log of the 12, did you put that a parenthesis after that? That's why. Yes, because you have to tell it you want just the log of the 12, then divided by the other log. Now you'll get it. Perfect. All right. Now that was very, very, very important at one time, because at one time calculators only did common logs and natural logs. And before that, there were tables of values for common logs and natural logs. And people would say, oh, if I want to do log base 3 of 12, they'd go to the table of values, find out what the common log of 12 was. They'd find the common log of 3, and then they'd divide to get the value they wanted. You guys are spoiled in some ways, because nowadays you don't have to do that. So here we go. I'm going to tell you this because it's not a big deal to me, because you might as well be able to use it. So I'm going to look at Desmos real fast. I'm going to pull Desmos up, and I'm going to put it on the board. Here we go. All right. Log base 3 of 12 is what I just did, right? I'm going to come down here and click the little keypad. I'm going to come over here to functions, this guy right here. And I'm going to go to miscellaneous. And I want you to look right down here. You will see above this funky look, and this is the Greek letter sigma. It says log, and then down here it's got a blank for the base. I'm going to click it. And it lets me put any base I want in there. 3 of 12, boom, answer. So now Desmos does that for you. Okay, if you have a TI-83, and if you have a new graphing calculator, it does it. So I'm going to show you that as well. So here we go. I'm opening up my, why did it not? Oh, here we go. It's opening still. Whoopsie. Okay, so here's a graphing calculator, right? Okay, if you hit alpha and you hit window, which is the F2 button, you will notice that number 5 says log base. I'm gonna hit number 5 and it shows up, and now I can do the same thing here. I would put in a 3, boop, arrow over, put in a 12, boop, boop, enter, and I get the same answer. So now calculators allow you to put in any base you want. At least the higher level calculators do. These, no. These won't. But Desmos does, and a new TI graphing calculator will do it as well. So you really, the change of base formula is not as valuable in some ways for you, but it will later on, and I'll show you that when we start doing equations again, you will need it sometimes to solve equations. And when we get to one of those, I'm going to make sure you highlight it and look at it and understand that better then. Okay, so we're going to wait. We're going to work our way to that kind of a thing. So right now, you have to understand what the change of base formula says, just the basic idea of it. All right. But you could find any of those you want on Desmos or a graphing calculator. You can do log any base you want, and it will give you the calculations for it. Okay. Are we okay with this one right now? And as I said, it's not as important, but I still have to talk about it because later on it will be important for you. When we will see some equations where we're going to use it. All right. What do you think? Overall, you feel pretty good about this, hopefully? We're going to find out. We're going to find out. I got the assignment written down here. Let me write the assignment down for you guys. Here we go. And I'll have to take, hold on, I'm going to go put this on, I'm going to have to go scan this thing because you guys don't have books here. I'm going to have to, I got to remember that. I got to start scanning these in advance. Okay, so and I'll put these online in a second. I'll just take pictures of them and post them. So, just pick some problems I really seem to like when I looked at them. I'm going to post these online. I'm actually going to go down and scan them. It's just so much quicker. So you guys can just write that down. I'll be right back. I'm in a good mood. How about you? Okay. So let me take this and you guys all write this down. Because what I'm going to do is I'm actually going to put the first page up there while I'm posting it. So you can kind of look at it already. As soon as my email receives what I just sent myself from the office. I know it's a long distance to travel. Oh, come on. This is ridiculous. Redonkulous. What is going on? I have the Google M on my screen and nothing's showing up. That's never a good thing for Google Mail. What is going on here? Is our internet all messed up again? Oh, there it is. Come on, really? I'm sorry, guys. This makes me mad that it's not. Where is this thing at? I was just going to try that. That's not going to work because I'm zooming this. I'll give you the three. The first ones are. Oh, you can't even do those without me. Ah! Technology. Beautiful, right? I cannot believe this blasted thing. There, finally got it. What do you know? Send yourself an email from the office. This took a while to get here. Okay, let me pull this over. And at least you guys can start. If you wrote the problems down, I'll zoom in. Come on, go in. Whoa, that didn't help. Oh my goodness, what is going on now? What just happened to that thing? Let's try that again. It's not going to let me go any more than that. There we go. Can you guys see that for right now? Until I get this posted online? Okay. Gmail. Save this. Download. Save as. Algebra 2 block. Choose a different folder. Okay. Now let's go to our classroom. There is classwork. Create. It's there now, for those of you that want it. Bum, bum, do, 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 do. I think we're good. Okay, that's good. Sign in. Sign in. Good. Submit. 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 Mm. Right there. It is, you're right. Yeah. This three, no, because this three is only one with the x. So you can't put it in front of, you have to expand this. It would be, yeah, exactly. You're right.
Would it be as an exponent to x squared?
No, you can put it out in front of that one, but it's in the wrong, it's in front of the wrong one. Let's have a great one. See you tomorrow. It's a Friday. Thanks, you too. Yeah.
We have a quiz tomorrow.
We're not gonna have one because things are gonna live longer, so.
Okay.
I mean, I thought about, if we do have one, it'll be the second period tomorrow. We might just do one on the basics of logarithms, like expand, just like the basics. Do you understand exponential logarithmic form? So we might do a real basic, but nothing that's gonna take a long time. It could be a 5-minute quiz.
Okay.
That's all.
I meet with a counselor today, and I don't really know her.
Who is it?
Miss Phillips.
Miss Phillips. Annie Phillips is East Unit. I think she's East.